On the 24th of April 2024, I did a presentation at the JetBrains offices in Amsterdam about Kotlin. My presentation had in its title Kotlin Mysteries, and the idea was to present curiosities about Kotlin. Now, the background story to this and how I ended up doing this presentation there at the office is an interesting one. I was essentially minding my own business on X, formerly known as Twitter, just discussing things that I saw in Kotlin that I found a bit odd, and they kind of challenged the idea that Kotlin is super perfect. Now, a bit of background here. I am a Kotlin developer now for about 5 years, and before that I was constantly just doing Java for a long time. And the switch to Kotlin, or you may call it a switch to Kotlin, but let's say my familiarity with Kotlin, that process started 5 years ago, and I was very interested in the language. And then I realized that there was this movement constantly saying that Kotlin was an upgrade to Java. However, I can understand why people mention that somehow Kotlin may be an upgrade to Java. I disagree with that. I think Kotlin is a new language that has created new kind of paradigms, or at least introduced new paradigms in this language. And with that, it has created other kinds of problems, which is only natural when a language is evolving. But I was discussing these topics on X, and I was discussing this with people that do have a lot of experience in Kotlin. Some of them actually work for JetBrains. And in the middle of this discussion, someone came along, someone by the name of Rafael de Leo, and he asked me if I would like to make a presentation about Kotlin, and I was thrilled when I got that invitation. And then the next thing was he mentioned that I would make this presentation at the JetBrains headquarters in Amsterdam, and I was of course thrilled with the idea to do that presentation. And for that, I am very thankful that the opportunity was given to me. And about that, so Rafael de Leo is a board member of the Dutch Kotlin user group. The Dutch Kotlin user group is also known as NL-KUG, and that means Nederlandse Kotlin user group, which in Netherlands you would say Nederlandse Kotlin gebruikersgroep. And of course, this group is a group that has support by other companies, and the company that supports it, I think for the most part, if not 100%, is Zabbia. And I thought, okay, so all of this is happening because of Zabbia, JetBrains, and NL-KUG. So I was very thrilled because it feels like a very prestigious, and it is a very prestigious combination. And so I got invited to it, and the first thing that crossed my mind was, of course, the exact topic that we were discussing on X. And so I made this presentation for it. And when I did the presentation at the JetBrains offices, which, by the way, this is me doing that presentation. It's the only photo I have of the event. Let's say the reaction to it and the comments I got from from my presentation, they were really, really good. And I felt like at some point, okay, so I might actually do a video about this exact presentation, because actually people found it to be very useful. I made the slides available on Scribd and on SlideShare. You can find them on the description to this link, but that's the only thing that's available online at the moment, not exactly my presentation. Now, in this meetup, there were other people presented it as well, and we were three different people that made three different presentations in the whole session. It was organized and announced on the meetup website. You can find the link also down at the description, so then you can see more details about what the other sessions were about. And this is the story about the start of this presentation. So, having said that, let's get into the presentation and find out what I have presented there. And this is also a session that will enrich what we presented on these sessions, because in my presentation I had to compact everything in 30 minutes and I wasn't able to do any practical exercises, and that's what we are also going to do in this video. So let's get into it, and let's start with my presentation called Decoding Kotlin, your guide to solving the mysterious in Kotlin. So the topics for this video are nullability, what happens when we work with the Spring framework, and what can we do to force nulls in non-nullable variables and fields. The second topic is inline and cross-inline. We are going to see the decompiled code and see why do we have to use cross-inline, because sometimes it's not very clear why the compiler forces us to use cross-inline when it appears that it does absolutely nothing. And maybe it doesn't, but we'll see that later. The other topic is tail recursivity. Kotlin introduced tail call optimizations, and therefore introduced a keyword called tail rec. This is something new for the typical Java developer, something fairly unknown. And as coming from a Java background, when I saw this first in the code, I didn't know exactly what it was, and it felt a bit strange because other languages have this for years available, and Java has been left behind in this regard for a long time. Maybe also because, at least in my fieldwork, I've worked mostly with a lot of algorithms, a lot of database access, connectivity, working with data structures, but never to a point to need to use tail call optimization. And so this was new for Kotlin, and in this session I want to clear it up what it actually means to use tail recursivity and tail call optimization. The fourth topic is about data classes and how data structures actually work in Kotlin, and what is the difference when we are using frameworks like the Spring framework or Quarkus, and how the decoration pattern can be very different in Kotlin than in Java, and also how can we, oddly enough, just make multiple tries to see if it works and then just fall into it just works philosophy. So the idea is also to clear up that. And finally, a curious case. This is the fifth case we are going to go through, and this is about delegates. What are they, and how can the decorator pattern have a role here, and how can you potentially use it in the future? But first, a little bit about me. Now, I didn't make a presentation I didn't introduce myself during my presentation, but for this one I will. So, my name is Josh Peresinha. I've been a software engineer or software developer for over 10 years. I've worked mostly with Java, Kotlin, Groovy, and Scala, although the longest time that I've worked in any of these languages was with Java. I am the owner of this channel for about a year, and I am a Spring professional. I'm a certified Spring professional of 2021. I'm a Java certified professional, and I am a Kong champion. Nullability. Kotlin promises a guarantee of null safety. Although we can use nullable members in our classes, We really shouldn't whenever possible. And what does it mean, whenever possible? The reason why we don't want to use nullable members in our classes comes purely out this fundamental principle. We want to predict our code. And in Java, one of the things that happens, I arguably more often than in Kotlin, are null pointer exceptions. And the reason for that is that every single object that we can assign to variables in Java can be nullable, can be null. And so all the variables and fields and all the class members in Java, they're all nullable. So we can give them null values through our code. We can assign null values. And so for that, I have created an example. And the example starts with the database. And the first thing I am creating is a car parts table. Important to keep in mind is that the whole project is about car parts. This is I wanted to create a topic for the examples that we are looking at, and I thought car parts was ideal for that. And so we can go through all of these columns. I've created an ID, of course, and I've created a name, production date, expiry date, barcode, and cost. They're all self-explanatory fields. And I also created a sequence for the IDs that we are using. And this is the table that the values on this table are going to be mapped to via a CRUD repository. And this is the mapping. So the ID maps to ID, name to name, production underscore date to production date, and expiry underscore date, and so on. So all of these get mapped to our class. If you noticed, you can already tell that the table allows null values, and because I didn't specify not null in every single column, but in the fields of the class, I am specifying all of them to be non-nullable. And then I am inserting values into our table. The first car part is a screw, and it has the current date as the expiry date. It has also as the production date, the barcode, and the cost. And the second car part that we are introducing is basically the same, but the only difference is that name now is null. If we introduce this in the database, then how would that play out? How is that going to play out in non-nullable members that we have defined in our data class? If we are coming from a Java background, this might sound a strange question, because we can see now that it is possible in the database to put a null value. And what would happen in a data class? I would argue that everyone, or at least most people, would find without knowing better, would expect the code to fail when reading the data from the database, and that we would never have a null in the name. However, this test will check that situation. We will test with this simple test if indeed the code fails when trying to get the value. So for the typical Java developer, the expectation would have been, when we run find all through the database, that this would just fail and throw an exception, probably a null pointer exception, because none of these names can be null, and therefore none of these names can be null, or better said, cannot be assigned a null value. And so when we do a find all and we map this to our data class, the expectation would have been that the code would just break. So let's have a look at an example and see what happens, and then answer to this question: is this possible? All the examples for this presentation are located in a project that I have created on GitHub. It sits under my own handler, that is JNation, and you can find it in Kotlin Mysteries. If you check out the Kotlin mysteries, you will find a project that contains a lot of modules, and the module that talks about nullability for this example is the car parts manager. And if you go inside car parts manager, we will find a project that essentially is a Spring Boot application that contains all of the things that, well, all of the standards that we need to use to create an MVC application. And in this case, we have a controller, we have converters, we have a domain, a DTO, a service, a utils script, in this case just to use a logger, and then finally we have the car parts application with the Spring Boot starter, and then we run the application this way. Another part of the application is the usage of Flyway. Flyway is being used over here to create our database. As we have seen in the slides, here we have the create sequence and the create table car parts. And as you can see, in none of these fields of the database or the columns of the database, none of them are non-nullable. All of them are nullable. And then finally, we add elements to our database. We add two entities. We add car parts that has a name called screw, and the second is where screw is null. And finally, we have the application properties. This, if you are experienced with the Spring framework, you already know this. So we essentially, the most important part here is the data source. We do have Swagger if you are interested in making tests in Swagger, but this is basically what it is. Now, the interesting part of this application is that I have made it specifically to test the nullability example. And so that test is located over here, and what we do is we inject first a DAO. This is a repository, a JPA repository, and there we just retrieve all of the car parts from the database with find all method, and finally we'll filter them and we try to find if there's one element where the name is null. If we run this test, is thus the question, will this work? Another important thing to mention is that the test doesn't start on its own. It's actually started with the usage of test containers. So there is a whole Postgres container that starts here. And because of the execution of the Spring Boot application, the create table and the inserts will be run. And then when we start this test, the data will already be in the database. So let's see what happens when we run this test. I will also debug it so that we can put here a breakpoint and see exactly in real time while the code runs in runtime execution what happens to this name field. And as we can see over here, the first name is the screw, and this is expected. And if we go up to the second, then we see that the name is actually null. So what will happen is that the filter has found one matching element, and this matching element will now be returned, and that should have thus the size of 1. So if we let the test go, we will see that the test, the result is green, the test is okay, and we have just tested that we can set a null value to a field in Kotlin that is non-nullable. So this example is a bit of a challenge to the idea that Kotlin is null safe. It is null safe. The paradigm is implemented for the most part, but there are these curious cases that we need to be aware of. And to complete this nullability example, it's also interesting to find out what actually happens to cause this to occur. And of course, you may have already guessed it, what happens is reflection. And this is what many of these frameworks actually use in the background. And because of that, we get this problem. And it might not be just because of that, but for a good part, yes, it's because of that. So now let's look at another example, and this example is indeed with reflection. So, the reflection example. I have created a copy of this car part DTO in another project, and I'm setting it all of the mandatory values that it needs to its fields. And we will print out the car part DTO, and then the field that we are going to use is name, of course. We set it as accessible, and we set the value to the name field to be null, and then we print the whole car part. Then we make an assertion if the name is null, and then finally we print the result of the assertion, so therefore by making two assertions. And thus the question is, with this car part DTO data class, is this possible? So let's look at the example in IntelliJ. So in this example in our project, we will find that we can set a null value to a non-nullable variable. And that example is located here in car parts nullPlay. In this car parts nullPlay, we can find we can find one class and one script. This is the car part DTO that we just saw in the slides, and in main.kt we can find this whole example. The first bit we have seen, we create a car part DTO instance, and then we print it. Finally, we get the field from the car part DTO class, we set them as accessible, and then we set the value to be null. We print it, we do two assertions. One, we check for it to be null, and the second one, we just print it. Let's just run this, and before we run, let's think a bit why this test will work. Why does it actually works? So the test runs okay. We can see that the first one, the first instance has the name equals name, the name is name, and the second example with a modified instance, we can see that the name is set to null, and then finally the assertion results true. And the code is allowed to go through because the assertions the result is true. What this tells us about the null-safety paradigm of Kotlin is that however it is very, very reliable, it is not immune to the actual virtual machine, which doesn't understand non-nullable fields and variables. The virtual machine has no idea what is nullable or non-nullable, so everything can have a null value. And this is logical because the Java virtual machine works with a compiled bytecode, which essentially works as a middle layer between our source code and the assembly code that is used to run everything, including the Java virtual machine in your machine. So this is one important and this is important to be aware of, because I can tell you that a lot of the times that I've been working in Kotlin, this problem came up, and before we could realize what actually was going on, we actually had to debug the code. And if we know this beforehand, we can help going through slightly or very embarrassing situations where you realize that you have spent so much time, and actually if you had known this before, then all of that investigation would have been avoided. So let's get back to our presentation and go to the second topic of this presentation, which is inline and cross-inline. Inline and cross-inline can be used in combination with each other. Inline provides bytecode copies of the code per each call point, and they can even help avoid type erasure. Let's stop here for a minute. They can avoid type erasure. And if you don't know this, maybe you have not worked with more complicated projects in Kotlin, or maybe you are just starting. But Java has this thing that has always created a lot of headaches at work, and that is type erasure. We create our lists or our arrays, or we create complex objects that have generic types. We create a lot of generic code, and then we run into some points where, because of type erasure, we don't have the type definition anymore, and we cannot perform some operations. Some people then move on to use tricks with reflection, and some people move on to actually don't use generic types at all, which is a bummer. But in Kotlin, you can use reified, and that in combination with inline can avoid the type erasure issue, because it keeps the type for each call point. So that means that you will have different code for the different types, and therefore the code is still recognized during compile time and is still recognized during runtime. But that is one curiosity. The big problem comes with the usage of cross-inline. Cross-inline improves readability, some safety, but nothing really functional. So why was it created anyways if there's nothing functional? Well, one of the points of Kotlin is really to make code more readable and simpler to use, and it adds a lot of features that that developers have complained about Java. That's part of their paradigm, that's part of their philosophy. But having said this, sometimes we just want things to be functional and we want to see them working. So why does cross-inline even matters? Well, if you have worked with inline, with higher order functions, you will probably have realized at some point that the compiler forces you to use cross-inline. But let's look at one example before that happens. So this example is a call engine cross-inline example, which uses a function by that name, and that function will receive as an input argument another function called start manually. Start manually is a function that returns nothing, and what it does in this example is the start of a car, and that is our start manually function that we put as an input parameter. By making this call, we then run a loop, and we then print this is the start of the loop, and then we call introduction, and in introduction we just say print line get computer in the backseat, and then we return introduction, we print this is the end of the loop, we print engine started, and in introduction we just print the local date time now, and then we call intro, which is essentially a print line, get computer in the backseat, and return introduction, and then a return introduction. These are a lot of calls, inside calls, so hopefully you were able to follow up until this point, and if not, please leave a comment in the comment section of the video. And this is the compiled code. The compiled code has essentially removed the call engine cross inline to actually inline it at the call point. So that's over here. And then it is going to make another call to introduction, which is then going to make a call to intro. And if you have been looking carefully at what this whole thing is doing, you notice that the start manually function is nowhere called. And of course the bytecode doesn't have this. At this point, the compiler and at design time, this IntelliJ will not complain about anything wrong here. It seems a very easy code to compile, and there doesn't seem to be a reason to receive a warning about it. But we will get an error once we call the start manually function. And then IntelliJ will force you to use cross-inline. And if you don't use it, the code will just not compile. So let's look at what happens. We call we call start manually. We need to put cross-inline as a modifier to it. And then the decompiled code looks very similar. The only difference is that introduction is called with a function as an input parameter. So this is the implementation of a lambda in Java, and then we call the introduction, and then what also happens, this is the introduction function, yeah, and then we call the invoke, and then what happens is that we call start manually inside introduction, and introduction is thus is thus a function that calls that receives as an input argument another function And this function is the combination of print line get computer in the backseat and the call to start manually. That of course gets inlined, and what happens is that the invoke of intro becomes this. So the function starts manually disappears in the bytecode and gets merged into the invoke that is the call to intro. But the problem here is that when you are doing this for the first time in Kotlin, the first question that comes to mind is, why do we need crossinline anyway? Because it seems like it doesn't make any difference in terms of the bytecode. There doesn't seem to be any change at all, and it just seems to be a notification, just some kind of reminder that that this is a function that is being called inside an inline function that then will become inlined when being called inside with introduction. What it actually is doing, what crossinline is doing, is avoiding, is making sure that we do not make non-local returns. So this is a local return. So the return to introduction is possible. The return to loop shouldn't be possible. The return to call engine crossinline shouldn't be possible. But the fact is, if you remove crossinline as well, the compiler will not work. And so you've got already two questions going on. The first question is, it doesn't seem to be doing anything functional. The second question is, if it is about safety, the compiler is already saying that this isn't possible if we don't use crossinline, even if we don't use crossinline. And if you look at inline, the modifier here, you have to think that the function, this whole function has to be inlined. So if you return to loop or if you return to call engine, think about how complicated it would be to inline this function anyways. If we go to call inline and we decompile it, we can see this, what we have here. But think about, for example, in this case, we have a return to introduction. So this is very easy to map in our brain that the invoke will have the whole function inlined, the whole this whole print and the start manually completely inlined. But if we had a return to call engine crossinline or a return to loop, how would this even look like in the decompiled code? It would probably be extremely complicated to do that, which is also part of the reason why these operations are not possible. And so you get the feeling, you start arguing, why do I need crossinline anyways? Well, there are some cases where crossinline is actually necessary. In our example for crossinline for safety, we can find a simpler example, a simple code that essentially is an object called special shop non-local return. And what it does a non-local return to main, and what it also does is call a function, in this case an inline function that is also a higher order function that receives a function as an input parameter called choose items. When we call go to the store, we print make purchase to the console, and then we just return main. And inside that go to store, of course, the function gets called, this exact function, print line, make purchase, return main, and that happens after we walk in. So this actually simulates going into a shop to buy something and then walking out. The problem with this function right over here is that it returns to main, and so it's almost like saying the customer walks in, makes a purchase, but that customer never leaves the store. And so what's interesting is that since this never gets printed, one of the things that the decompiled code does immediately is that it doesn't ever puts the never walks out code in the bytecode. It just finds it as that code, and it doesn't get there anyway. And this is interesting because maybe we had in these cases, if that code, maybe there's a goal there. And in this specific case, there isn't really a goal. You want to leave the shop once you buy something, unless you're buying for more, but eventually you will want to leave the shop. And so whatever happened here, whatever the developer was thinking, it probably wasn't intentional, but it still happened, and therefore the program runs erroneously. It doesn't match the requirements that were set up for the code. And so another way to do this is like this. Now we look at exactly the same implementation. The only difference is that we are only putting over here this cross inline. So whatever happens, whatever the developer does, the code will never allow to make non-local returns, so only local returns. So in this case, you want to return the function, well, you want to return from the function, well, then you return to go to store. And there is no alternative here. And so what the compiler will tell you is that this is not possible. It's not possible to do a return main as before, because we have set it up to be, we have set out our function implementation to be cross-inline. And if it is cross-inline, we are specifying that no non-local return is allowed. And so this walks out now prints, of course. If we read the code, it prints it out. But the only role that this cross-inline actually did in this case, where we can see somewhat a quasi-functional change, is that the compiler does not compile this code if we are using cross-inline and we try to make a non-local return. So a return to main will never work in this case. Cross-inline, if we don't understand very well how it works, can be a bit of a headache when you're trying to figure it out what to do, because normally what happens when we use things that the compiler forces us to use and we don't understand why, our inquisitive mind will want to try and figure out what that does. And normally what developers do is they try to make small pieces of code to run this and see what it actually does. When in fact it is literally what it says in the documentation. So it prevents the usage of non-local returns for all cross-inline, for all functions marked with cross-inline. But it doesn't specify exactly why is that. The examples for inline are available in the car parts inline module. And if we look at the car parts inline module, we can see that there are some classes over here. You've got some classes in Java, and you've got some classes in Kotlin. The Java classes are some experiments that I've done. You might find it interesting, but that's a bit off topic of this project, of this video. So what we want to do is to first check the car parts inline cross-inline launcher. We have the extended car parts example, but more important than everything, we've got here the first example that I showed you in the slides. So this is an example that has the cross-inline all placed for us. So this all works correctly, but let's now try and remove cross-inline and see what the compiler says. So the compiler immediately says that this start manual can't be called here. Either we remove it or we apply cross-inline to it. This modifier makes sure that we can inline it. Here it says, can't inline start manually, it may contain non-local returns. The message is it may contain. And the reason for that is that we may want to return not to introduction, but we may want to return somewhere else. For example, to call inline. If we do this, the compiler will not let us. And if we remove this, the compiler will also not let us, but it's already recognizing call inline, the call engine cross inline. And so in this case, we also get the message that the return is not allowed here, but here the compiler does not force us to use cross inline. This is the bit where it gets confusing. So why is the cross inline about if the compiler recognizes itself that this is not a possibility? So for this specific example, we just stay with the idea that it is safer, that it is more readable to use cross-inline here. But we don't see any example here about how safe the code may be. For that, I have another example, and I think that example is here in the special shop. This special shop is the example that I've created. So a customer walks into the shop, wants to buy a product, and then wants to leave. The compiler forces us to use cross-inline in this situation over here. Not the one at the top, but this one over here. So here, the compiler is not forcing us to use cross-inline. And the reason for that is that the function itself is not an inline function. So this is pretty much very easy for the compiler still to interpret and to create bytecode from it and apply the necessary transformations. However, there is a problem with this first code. As I mentioned before, the return is to main, so that means that this code here never gets executed. And when we do the decompiling of this code, if we go here to Tools, Kotlin, Show Bytecode, and we decompile it, we will see a very interesting fact, and that is that this never walks out is never compiled, and we can see that by the number of times it appears, which in this case is none. So there's no printing that never walks out because we do this return and the compiler recognizes that. And one thing that the compiler does not do now is recognize dead code. This is almost like dead code. We will never be able to reach this piece of code because of this return to main. In the second example, which is the shop with a local return, what happens here is that we are returning to the go-to store, but we are also using cross-inline. In this case, it's not that cross-inline is mandatory. In this case, is that we can protect our code from a developer that may make a mistake in the code. If we say that it's cross-inline, then that means that the developer must only make local returns. So no non-local returns are allowed. And that's exactly what we are achieving here, because if we now try to return to main, we get a somewhat antagonistic error message to what we've seen before, although it's exactly the same thought process. The return is not allowed here. And why? Because cross-inline, the function that we are defining here in this go-to store, this function is a function where cross-inline has been applied, and therefore what happens is that we can only make local returns. So return to main is strictly forbidden. It doesn't mean that a developer can't go over here and just delete cross-inline, and then it will work. But that's the problem with not knowing this. Is if a developer removes cross-inline and is still allowed to return to main, that means two things. It means that the developer made an unintentional mistake because the pressure was to get the code to be fixed, and it is fixed now, but it will not run the same way as before. And the other thing is that the developer just don't know what cross-inline does. And so if the developer knows what that is, then the developer knows that doing this is a no-no, and that this return can only be a return to go to store, or simply put, just I think a return will never work, or no return at all in this case. So now let's move on to the third part of our presentation, which is about tail call optimization. So Tail call optimization is something that has been an issue in programming languages, at least in talks, since the end of the 1950s, which is a long time. Some languages have adopted this to work implicitly, others to work explicitly, and we come to this day and age where Kotlin does something like that, and which I will explain in a minute. But for now, let's just say that since the late 1950s, TCO was already a theory intended to be applied to tail recursivity. It allows tail recursive functions to be transformed into iterative functions in the compiled code for better performance. Now, is it just better performance? This is something that is frequently said, but it does not mean that it's the main goal. So what is the catch? So what is the problem? So let's have a look at this and understand what it is. Let me say just right off the bat that the tail call recursivity, the tail call optimization for tail recursive functions isn't really designed for better performance as a first goal. But we will see what it is if you follow this presentation. So let's see. I have created, of course, a simple example in this case, at least in my view, and that is I've created different sealed interfaces and different data classes that are going to implement these interfaces. And what it is, again, is about car parts. And we have a car part, a complex part, and then we have a code that creates a structure of these parts together. Essentially, what we want to create is a car, or at least a representation of a car with different car parts. Each car part has a weight, and the idea is that with a recursive algorithm to calculate the weight of all of these parts together to get the weight of our car. There is a function designed for this, and this function is called total weight. And total weight is recursive, and not only recursive, but also tail recursive. How do we identify a tail recursive function? It's very simple. When we look at the definition of the function, we need to think about the calls that are being made to this function. If the recursive calls are the same as the recursive function, so if the call point is the same as the last call to the recursive function, then we are in the presence of a tail recursive function, which we can find with these total weight, which are the last possible calls of this tail recursive function. In this case, one of the things that the compiler offers us as a functionality are two things. One of the things is to allow the code to be compiled with tail call optimization, and the other thing is to recognize the tail recursive function as tail recursive. If we apply a tail recursive modifier or a tail rec modifier to a function that it is not tail recursive, then the compiler will fail. But this is not the case for this total weight function, and so because we have applied tail rec to the function, now we know that the compiler will do TCO. But what is TCO and why are we going to do this? And before I show you that, it is important for us to notice that look at this recursive function with a more global perspective. We don't see any variable here, any var. We don't see any mutable variable. And this is important to keep in mind because many times when we do recursive functions, we may be tempted to use mutable variables, and especially when we make iterative algorithms, we almost always use mutable variables. And of course, Kotlin introduces not only null-safety paradigms, but also it hasn't per se introduced the concept of null-safety, or immutability, but it is a language that supports itself a lot on immutable paradigms. At least from a user perspective, we are not supposed to use mutable variables that frequently, and we will see that tail recursive allows for this as an advantage. But let's have a look at the example now. So I have the example here again in this slide, and what we want to see is how it looks when it's being decompiled. And if you notice, the first thing that is quite striking is that purely because of the fact that I have applied a tailrack modifier to that function, the compiler changes it completely. So if we look at this decompiled code, we hardly recognize our function again because it has an endless loop and it doesn't have any single usage of a recursive function. It keeps in the while loop until one condition is matched, and then it returns. So here we have a bunch of anti-patterns implemented. And also we see that we have mutable variables. But one thing that is curious is that the calculation is being done using mutable variables. We are returning out of an infinite loop. The code is quite horrible in terms of structure, in terms of the way it uses ifs, in terms of using instance of. But here's the catch. This algorithm implemented this way is way more efficient than the tail recursive function if no tail call optimization is applied to. So if we don't use tailrack as a modifier, the function will be implemented just that way in the bytecode. And when we decompile that back to Java, then this is not what we'll see. We will see something very similar to our original implementation. And so it will still be recursive, and it might improve performance when we convert from a recursive function to an iterative function, but the greatest benefit is that there is no risk of stack overflow. The idea of not using stack frames is precisely to avoid stack overflows. So tail recursivity and tail call optimization are here to guarantee just that we don't use our code endlessly inside an internal loop that creates different stack frames up to a point where we get a stack overflow. We can get an out of memory here, we can get maybe slow performance, we can get CPU peaks using this conversion, but we will never get a stack overflow because we are not using several stacks to perform our calculation. Let's see that in the code and see how that works. So the example, of course, are here in the project, and the name of the module of tail recursivity is tailrack. So car parts tailrack. If we go over to the project and we check out the source code, we see exactly what I have mentioned in the slides. This one we don't really find too much. Here we don't really find too much differences from what we saw in the slides, but it is important also to just have a look at how this calculation is being done. One of the things that we can do if we run the program just like that is, well, first have a look at how the car is being created. So the car is being created with all of these car parts with different names, and they all have different weights. We've created a car part, and not only that, we have created a list of cars. And so when we create this list of cars, we assign that to the variable cars, and then we use the total weight function to calculate the total weight of all of these cars. If you run this function, we will see the total weight of the car. There is 4,120 kilograms. We can also measure how long it took to perform that calculation. So we can do measure time in mils and do this, and then just print the result to the console and just see how fast it actually works. So in milliseconds the operation took 8 milliseconds, which is already fairly low. If we don't use tail recursivity like this, we can try and run this again, and now it takes 8 milliseconds. If we do it again, 8 milliseconds, again 8 milliseconds, again 11, and if I use tail recursivity again, it will take 8, 7, 9, 8, 11, 9. So you can see here that the performance isn't fantastic, or at least there's not much a big difference. It's also true that we don't have a huge data set, so and this also is not really a benchmark test, but it's only to show that the performance here has very little impact. What may have a bigger impact is if we remove tail rack and then go over here to our build and our tools and just say show Kotlin bytecode and then decompile that code, and when we go here to the function, then what we will get, let me see, so we know that total weight now is not being marked to be tail call optimized, and so if we look for that function, here it is. This is the function. So we can see that the function is returning the accumulated value of all parts, and it stops performing the calculation when the list of parts is empty. If the list of parts is not empty, what it does, it will keep on performing the calculation and add the weight to the total weight. So this means that for every one of these calls, we will get a result that will be a sum. Let me see here, current weight. Yes, so it will be a weight of the current accumulator and the following part, and it will keep on going until the list of parts is empty. And as you can see here, imagine that the list of these parts is never empty for whatever reason. Then we would get easily a Stack Overflow, and with an iterative function that will never happen. Even if let's just say that this parts list was infinite, it means that the iterative process will keep going. And the difference here is that with the iterative process, we have a space complexity of 1, meaning that the space doesn't change. We keep adding the weight to the car. We keep taking values from the list, but nothing really changes space-wise. It does changes linearly when it comes to time. And however, that doesn't change for this case, because again, we are using the same accumulator and we are using the same list. What does changes is the recursive calls to stack to different local stacks. And of course, a local stack takes away some space, takes away some resources, and the accumulation of all these stacks leads to a Stack Overflow. So now let's have a look at our fourth example of this presentation. In this fourth example, I'm going to discuss data classes and frameworks in Kotlin. Kotlin provides use site targets that allow us to specify where particular annotations have been applied. Sometimes we need them, and sometimes we don't. But why? So what I'm discussing here is when I talk about these frameworks, I'm actually referring to the annotations, and more specifically the use site targets, which was something that we generally ignore in languages like Java. However, in Kotlin the story is a bit different, and I will explain why. So here is an example working with data classes in Kotlin and using the Spring framework. When I create this table representation with a data class car part, then I see that it is annotated pretty much everywhere. And so the question would be, is this enough to make this class work? Because we can look at our data class, we can see that everything is immutable, so it seems okay. And then we say that, okay, I've got a table. This table is also an entity in our code for our JPA queries. Then I am setting the ID to be ID column. I'm saying that the name cannot be null, which is completely unnecessary in this case. But I'm also saying that the size, which means the length of the name, cannot be under 3 or cannot be over 20. Then I don't have any specific annotation for the production date, for expiry date, for the barcode, but I'm saying that the cost must be at least 5. And so it seems that this should be okay, but will this data class work? It turns out that this doesn't work. And the reason why it doesn't work is it is not an easy reason to understand, and especially not if you are just experimenting on your own and trying to figure out how things work with your own code and just performing experimentation. Even if you Google it or look it on Stack Overflow, you might come up with very wild, inaccurate answers to this request, even with upvotes and even with the green check mark. What actually happens is that Kotlin uses site targets in a different way. And we can see that example right over here on this other representation of the table. We've got a data class that represents the table car parts with an entity. The ID is annotated with ID to specify that it's the primary key. Then we say that it's a column for name. But then we see that our validations are now prefixed with this field. And this field is called the use site target in Kotlin. And what it does, it specifies that we want to apply this annotation to a field in the class. Why is this important? Well, one of the things is that in Kotlin, when we use data classes, one of the things that we maybe miss quite easily because we get caught up in this wave of how much better is the boiler code to have been taken away in Kotlin. So we don't see any getters or setters. We don't see the constructor even. We don't even see the actual arguments of our constructor, or better said, we don't see the parameters of our constructor. And now everything is very compact, and these are actually now called class members that represent a lot of those things. So if we decompile a data class, we will see still our getters, our constructor, our parameters and our fields, and our different accessors and our different properties. We'll see all of that, but this will work. So why is it different? Well, if you remember Java classes, these annotations would be applied on a field of that class. But if we set it just like this, think of it for a moment. Where does this field, where would this annotation go if we don't specify that it's to be applied in a field? How the compiler knows where do we want this annotation to be applied to? And another thing that might sound weird is, how come ID and column don't need any prefix and this still works? The reason why this is so doesn't have much to do with technology. It has more to do with the rules that Kotlin has established to make this work. So Kotlin has devised a plan for doing this. Now the reason why this comes about is because another thing that teams within the Kotlin world are trying to do, namely with Ktor, is to remove the access altogether of annotations and seeing how that plays out in real life, in real products. And so far, of the few people that I know that do use Ktor, apparently it has been a success. But let's move on. Because we are using the Spring framework in this case, and the Spring framework is widely used, and this is one of those issues that causes really a lot of confusion. So let's move on. In Kotlin Lang, we can find this documentation that tells us literally, and this is something that I took out of their website, it only says if you don't specify a use site target, the target is chosen according to the target annotation of the annotation being used. If there are multiple applicable targets, the first applicable target from the following list is used. So what happens here is that if we have multiple targets specified in our class, then Kotlin needs to make a decision which one is going to be applied, and that is applied according to this rule. First param, then property, then field. Let's have a look at a concrete example. If we use size as annotation, we've got that it has in its target, it's got specified method, field, annotation type, constructor, parameter, and type use. It also specifies its retention policy, repeatable, documented constraint, but we know with these annotations that it's being applied to the class. And the important thing is this target. It has all of these annotations. And so, if we have all of this, then which one would you say is the place where size will be applied in our data class? This would be the parameter. So it will apply this to parameter. And here's one thing important to know about parameters in the Spring framework. When Spring works with annotations and injections, and it uses these validations, one of the things that it doesn't like to use parameters. The AOP part of the Spring framework usually is more comfortable and is more compatible to using fields. And so when a parameter is selected and we apply these annotations to a parameter, they don't take any effect because the Spring framework isn't ready to interpret some of these parameters, if not a lot of them, if not all of the parameters that we use. So let's see a concrete example. In this case, I've got a car part that now this is the result of decompiling the car part just without using any use side targets. What we find here is something very interesting. The whole car part has been decompiled to have all of these fields, but we see that from the bytecode, what we get as a constructor is something different than what we should expect, or at least not here anyways. We see that all the annotations that where we didn't apply field to, namely size and min, have been applied to the parameters of the constructor. And what this means is that Spring aspect-oriented programming doesn't know what to do with this because it's not ready to interpret this. It will try to interpret everything that's in the fields, but in the fields we don't have any min or size. And so this will fail. This is not where we want them to be, but where they are expected. So now that we are empowered with the knowledge that I just shared, then we know that they will be applied in parameters, and then we know that this will not work, and that for these we need to apply field. And so the actual answer to this problem is to put the field as a prefix in our annotation. This is the use side target for size and min. And then we see that when we decompile this class out of the bytecode, we see that size has been applied to name, the field name, and the field cost. Since field forces the target, these annotations get applied where they should. The reason why the other annotations are correctly applied is because they do not have as many targets. And we can look at it now in the example that I'm going to show you. So let's have a look at the example. Let's go into Kotlin mysteries and let's go to car parts data structures. This car parts data structure is only an extension of what I've already created for the nullability example, but this one is specific for the data structures. It's literally a copy paste with some modifications just to see the differences and to focus on this part of the presentation. So let's have a look. In the car part structures, then we have a test or different tests that will make sure that we are able to test what is happening. So in this case, let me see, I've got a cost 10, Yes, then yes, I have an example here. Should detect an invalid request to the controller. So we are using mock MVC from the Spring framework. If you don't know, it's just a part of the test framework that allows us to test against controllers and allows us to test how the responses are being generated when we make requests. In this case, we want to make sure that we are sending an invalid body. In this example, we are testing the payload to the controller. So this one is a bit different than what I just showed you in the slides, but we'll get to the example of the slides as well. In this example, we are sending a payload, which is a car part DTO, and I've made it on purpose a bit different than the entity. And so the car part DTO has got something different, which is the field, which is the annotation positive, decimal min, and positive for the barcode and for the cost. So if we send the barcode with a negative value, this should fail, and that is what it's testing right over here. It's testing if the request is a bad request. If we run this test, it's quite obvious that the test is going to run okay. And the reason being is because we have said that the barcode must be a positive number. So positive in this case means that we are expected to have a positive barcode. There we go. So the test runs successful because we are testing an invalid payload. But look at what happens now if I go here to barcode and say that this decimal min, which is annotated with all of these targets, if I do this, but I remove the field, so I tell Kotlin to decide on its own where this annotation is supposed to be applied to. And let's do this actually for the barcode. Put field here again, field. And if I do this, this should fail. So let's run the code again. It still fails because I didn't change positive. And there's another thing. Both positive and decimal will cause the code to fail, and I'm not checking if one or the other validation has failed. So what I actually need to do to prove my point is to remove both fields. So let's see if it works. There, so the code now fails, and if we look at the logs, we can see why is that. If we go over here, then we can see that the reason why the tests fail is, first of all, well, we expect a bad request, and so if we expect a bad request, then that means that there should have been some sort of validation error in the backend. Let's have a look at the code and see now what has happened that allowed this request to go through and return a 200, which is right over here. So we expected a 400, which is a bad request, and instead we have gotten a 200. So our request went through to the car parts controller and to the create endpoint. This create endpoint is performs a validation to the request body, and that is the car part DTO, which, as we have seen, doesn't have any validation anymore for the barcode. The barcode is a negative value, and the cost, as we have seen right over here, the cost is number 10, and number 10 is allowed because the minimum value is 5, and it must be a positive value, so this matches, and the code just goes through, since these two validations are wrong now, and these validations don't work anymore. And before we continue with our analysis, let's just check out the decompiled code. So let's go here to show bytecode, and if we decompile this class, what we are going to see is that we've got all of the different annotations correctly applied to field, but we don't see anything with the barcode. So the barcode doesn't have a single annotation applied because the barcode has those annotations applied, unfortunately, to the constructor parameters, and so this will never work. But that's not all, because now our our invalid request went through to the converter, and there in the converter it gets converted to entity, and in our entity car part we still have the ID, the name, the production date, expiry date, all these things, but we also have validations there, which are the validations that we have seen in the slides. And here our payload matches as well. The size of the name matches. The barcode doesn't even have a validation, and so the code goes through to the validation and then comes back to the converter. And in the converter, when we convert this entity to a DTO, what we are also doing here is to log the car part that we are converting back to the DTO. This all goes well, and we also log in the console what we have tried to convert. And as we can see, we got from the database a car part that now has a negative barcode. Now, these kind of accidents have happened to us while making code and not knowing about these annotations. Everything seems to work. It is only when you start making the unit tests and realize that the bad cases don't really actually become happy cases, then you see that the annotations don't really work. The problem with this is that if we don't know the rules, it takes a lot of time to solve. It can consume a lot of time to solve these problems. But let's continue. And let me just now fix the test. So as we have seen before, what we need to do is put here field. And here we can just put field. But for me, this is one part of this story. The other part is how come the other annotations do work without field, and that we have seen already in the theory that if we as we have seen in the theory, we have seen that Kotlin will use will apply the annotation to a certain use-side target according to those rules. So let's go to this car part and pick one, for example, column, and let's see why column actually works. If we go in column to the definition, we see that it has two different targets. It has method and it has field. As we have seen in the selection list before, the second term that comes in is field. Let's confirm that in our rules. So if we go to the so if we go here to the rules, we will see that the first target is param, the second is property, and the third is field. So the third one is chosen, and the third one is chosen here because the one that we have in between is called method. Method doesn't even come in this list, is applied afterwards. So this is why column works. And if we decompile this, we are going to see, actually I can decompile it right over here, we are going to see that column is correctly applied to the field name. And this one doesn't need it because it doesn't have as many targets and it doesn't have so many variations in the targets that it contains. And so column and ID don't need to have a special explicit use-side target for this to work. Now we can try this as well. I have created tests for it. This is the domain. These are the domain tests, and I have here, for example, an invalid entity. The invalid entity here comes because the cost is 1. So the cost for this car part is only 1, which is not allowed. We are only allowed to have car parts with a cost value higher or equal to 5, because that's what this min field says. What we can try to do is something interesting, which is come here to the ID and say we want ID to be applied to a getter. Yes, to a getter. Will this work with a getter? We'll have to see if it works, because we have to see if a getter will work with Spring. If I put a getter here, we can see, yes, we can see that the ID has disappeared from field ID, and now if this is correct, we have explicitly said that the ID must be in the getter. And so if we go here to the ID, so this is Java, so there is a get ID, and the get ID does have the annotation applied to the ID. But if we run the code now, we should expect this to not work very well. In this case, we are waiting for an invalid entity, so this actually might work. No, it doesn't. It doesn't because it says probably that it has failed to locate the primary key of the table, which if I could not locate setter method for property ID. So not exactly not finding the ID, but it doesn't find the setter. Well, the ID is not applied to a setter, so this will never work. And so if we put that back and then don't specify any use site target and let that be applied to field, then this test should work. Let's see if it does. Yes, so the test works perfectly right now. So these are two examples, two situations, one with use site target and the other one without having it defined, without having it explicitly, of not so easy to understand situations that may come up if you are doing this for the first time. I know that this, even when you work with this for a long time, if you don't know the specific rule, you're probably going to find yourself trying, and that is trying and with multiple different use site targets and not really understanding what's going on in the background. And this is part of the reason why this part of the presentation is so important to me, because I don't want you to go through that. So we can continue to the final part of this presentation, and the final part of this presentation is a different example. It is a strange example that I discovered with the delegate annotation in Kotlin. It is something that we don't use a lot in Kotlin. I don't think I have ever used it actually in production projects, but I have made an interesting case for that. And delegates in other use site targets. This is the title of our last section of this presentation. And a delegation is a great part of the Kotlin language, and it is quite different than what we are used to seeing in Java. But how can we use this? Now, this is a question that comes up when you are working with Kotlin for a long time and you want to know what are these things for. Now, the delegate is one example, but I find it important because we may have use cases for this, and if we don't know this, then we will never be able to use it, because this is not something that comes up as instinctively as something that we think that it might be available in Kotlin. So let's do this. To give the example of working with delegates in Kotlin, especially with the delegate annotation, I have created an example with horns. I've created two classes, a car horn and a wagon horn. These are two different horns. The car horn will perform a beep, and a wagon horn, I don't know, I just put it to perform a boo. And that's it. And that's the difference between one and the other. Then I create two classes, two annotations. One is called delegate to wagon horn, and the other is called delegate to car horn. Then I am creating a sound delegate, and the sound delegate will be initialized with a horn, and it will have a get value. And this get value is important. Right over here, we must understand one important thing about delegates. When we implement delegates in Kotlin, we don't need to use them as a subclass of another class. We don't need to use an interface. Just as long as we have a get value implemented this way, then Kotlin will immediately know what this is and will be able to apply this class as a delegate. And then finally, I have created a horn pack, which has two horns. One is a wagon horn and the other one is a car horn, but they are not being initialized the way we usually initialize them. They are initialized by. So by indicates that we are going to create wagon horn and car horn by the use of a delegate, and that delegate is the sound delegate. So where is this being applied to? Is this being applied to horn or sound delegate? This is an interesting question. At least for me, it was an interesting question, because if I don't know better, I have no idea where this is going to be applied, because it seems like this use site target is being applied to the field wagon horn, or in this case the class member wagon horn or car horn or car horn. But this is actually going to be applied to the delegate, to the sound delegate. And how does that even work? So let's look further into the example. So in this case, we have these delegates. One is a delegate to a wagon horn, and it creates a sound delegate with a horn that is a wagon horn. And the other one is a delegate to car horn that creates a sound delegate using a horn that is a car horn. And this creates a sound delegate. And when we look at the getters, we can see another important thing, and that is that we now can also create getters for, or better said, the compiler has created getters for us. So that means the decompiler will create this in the Java styled way, and that means that we not only get the delegates as properties, as fields, private fields, but we also get the getters for the horns that are stored inside the sound delegates. And so what this means is that we can apply different use site targets here. We can apply a use site target for a delegate and a use site target for the actual value that we are returning. This is very interesting and can be very powerful, but let's look at that in our code. Yes, so what this means, no horn here, what it means is that there is no horn in horn pack. It is located inside of the delegate. But let's see how that gets, or how that got implemented in my implementation. Let's have a look. So the code is this one. And the project that we want to have a look at right now is car parts use site targets. And car parts use site targets only have two scripts. One of them is the main script that will essentially just run the program, and it will just let's just say it will press the buzzer for wagon horn and press the buzzer for car horn, but the actual code, the actual mystery is located in the delegate script. And in delegate script, we have the same code that we have seen in the slides, and an important bit of it is that what we are creating over here is the ability to somehow validate what we are creating. Of course, in this case, I'm not validating anything, but what's important to notice is that I can apply a certain kind of decorator to the delegate. So that means the sound delegate, because we have seen before the sound delegate has this applied to it right over here. And so when we run this code, nothing much special happens, only that we are able to press the buzzer and essentially just press the horn, and that's it. But this one is a simple example, and this is another example in our slides. Just to keep going on that example, and you probably already know how to interpret this way. We have here another delegate called sanitized name, and it implements a get value and a set value. We also see that we have created a part name DTO and an impossible part name DTO. The part name DTO is makes sense because we are applying to the getter of the name that it must not be blank and its size must be maximum 12. And the impossible part DTO, we are applying delegates to it and saying that the size must be maximum 12 and it cannot be blank. So we are using the same annotations but using different side targets. What happens in part name DTO is that the not blank and size are correctly applied to get name, whereas in the case of the delegates they are applied to the delegates, so that has no effect at the time of the creation of these class fields, because in this second case, in the impossible part name DTO, the code will fail, throwing an error that we don't have a certain kind of serializer for the delegate. And that is true because these annotations are specifically made for strings or for getters, but not really for a delegate. So these annotations will not, let's say, Spring will not be able to know what to do with an annotation not blank or an annotation size applied to a delegate, unless we implement our own serializer and or deserializer. So to test that example, I have created also this car parts service extended. You can find it also in the car parts data structure application. It's a bean that is created right over here, and this service doesn't get created with the service annotation. It's a bean as well, but it gets created manually using a delegate, that is this car parts service instance. So now instead of having an actual delegate, we use a service. And the reason for that is that we need a car parts service with the same methods as the car parts service, an extended version of it. To see these examples running, the impossible part car part DTO and the car part DTO, the best thing to do is to test the endpoints. And here are the endpoints. I have a post mapping name and a post mapping impossible for the part name DTO and the impossible part name DTO. For the part name DTO, we know that these will be applied, we think they will be applied correctly. And for the part name DTO, the impossible part name DTO, this will generate some kind of error. So let's try that. Let me see if I have. Yes, so in this case, we are going to test it live with the running service. Let's go here to database service and, or better said, docker compose up from the root. Yes, so now we are creating a database for our services. Once this starts, then we can start our application and see this last example thoroughly. There we go. So now it says started. We can now start our application. So it has already started, and now if I go to this file test request that is located on the root of the car parts data structures, then we can do the test for name, although we already know what's going to happen. It actually throws up, failed for argument 0 and it rejected on, yeah, exactly. So this test fails because we have created a very long name. So the validation is working for this. And so the serializers recognize this, the validation is applied correctly, and everything works really well. And we know that we if we pass the validation, then this should all work correctly. So if I do this, if I shorten up the name, then we see that the response is okay. So although we have created a part name with a delegate, we see that it works also in serialization in combination with the delegate. But now we move to the impossible part name DTO, where the code construction is the same, except that the delegates are not being applied to a string anymore, they are being applied to the delegate. And so when we run that example, even though we send it correctly, we are going to have a service, an internal server error, which will probably not tell us much information. So now what we can see is that an error has happened, and we can now have a look at exactly what has been going on. And what we get is a 500, that is an internal service error. And now let's see what has the server outputs to the console, and we see that in the console that something like Jakarta validation and expected type exception. That means that the engine behind the Spring validations is trying to use Jakarta to make some sort of validation, but what happens is that no validator could be found for a constraint not blank. So what happens here, we don't get that mapping validation that I was expected. Instead, we get another similar exception, and that is just that there is no validation for this constraint size applied to sanitized name. And sanitized name, if we look at it, it's the delegator itself. So we are applying this to the delegate sanitized name. Spring doesn't have a way to understand this, and it could just be that the version has been updated, but the whole point is that it just doesn't recognize how to apply this validation. And so we are left with an impossible part name DTO that doesn't work either for size or either for not blank or any other annotation of this sort when we use a site target delegate to it. So this is the curiosity that I wanted to tell about delegators and the delegate annotation. And if we go back to our slides right now, we will see, and here there is an example about working with delegates. What I have created is a delegation service that has a UUID, and this is stored as a public class member, and the field ID stays there. But what's important is the current date that we also store as a field, but this field will have two different annotations applied to. One is the local date time validator constraint, and the other one is past. Local date time validator constraint gets applied to delegate, and past gets applied to the value that is stored in the delegate by means of the getter. So we can also look further. If we decompile this class delegation service, we will see that we only get the getter for the current date that will search that value in the delegate itself, and then we see that the delegate annotation local time validator constraint gets applied to the delegate, and past gets applied to the getter of the current date. We will see an example right now about how this works, but first we need to pay focus to these two annotations and where they are being applied to. Keeping this in mind, let's have a look at the example. I have also created a more complicated example within the data structures module, and that's also what I want to see. At this point, I didn't have much time to finish off the presentation, so this part was very much essential for this part of this whole video, and it is essential because this is where we're going to see something interesting about this delegates that I wasn't able to explain during the presentation. But now we have all the time in the world to have a look at it, so let's do that. In the controller, I have created different endpoints, and these endpoints are specifically created for the example of the delegate annotation and the delegate. So if we go right over here to create car part extended, we will see that we have a validation for car part DTO, but we also have a validation for the delegation service. Let's look at the delegation service first. So the delegation service gets injected when we call that method. And what happens is that the delegation service carries with it two interesting facts. It creates a class member called current date, and it is created with a UID. But this UID is only for log purposes. What we want to have a look at here is what will happen with these annotations now. As you probably already guessed it, if you've been if you noticed what happened in the slide about delegation, the last slide with the horns, you probably already know that the delegate will be applied. The local datetime validator constraint will be applied to the delegate, and the getter will be and the past annotation will be applied to current date, or better said, the getter of the current date that is located inside the local datetime delegate. Let's have a look at the local datetime delegate first to understand how this is working. In the local datetime delegate, the only thing I have is a get value. And this get value, the only thing that it does, it returns a local datetime now. This is only a class, and at this point we don't have any instance of it. The instance, however, is created over here when we create the current date. And what now happens is it will also apply the local datetime validator constraint to the delegate itself. Let's look at what this validation means. This validation is a manual validation, and the reason I made a manual validation is because I wanted this one to be used in whatever site target I wanted. And so I wanted to be completely independent to apply the targets I want to apply. There are annotations in Jakarta that you can use, which are assert true and assert false. They are somewhat dynamic, but we cannot control the targets. With this one, we can. And so the validator, the implementation of the validator, this works if your computer, by the way, is configured to use a country that either is empty, or is it the Netherlands, or is it the US? Everything else will fail when extracting the country from the locale. So be aware that these tests might not work in your machine if you have a different configuration in your system, and if your local default country is something else than this. One thing that we can do right now is to run all the tests for the car parts data structure and see what happens. So if we run all of these tests right over here, the test will run correctly because I am running a machine that I believe is configured with a US system. Okay, so this is not a problem. But if I put here something like, for example, that I'm only accepting that I'm only accepting locales of kittens country. So I believe at this point that there is no computer with this country configured. So if we run the tests, this should fail in one specific test that I have for this situation. But let's have a look what happens when we run all of it. So there we go. So one test fails, and this is the should send valid request. Right over here, a valid request to extend it to the extended request. So what happens here is that when we send this request, the locale will fail for the delegate, and therefore what will also happen is that the current country is the US, but this will fail because we can see here for argument 1
because the value is invalid. Now, doing the validation this way, I didn't bother to change the description, but it is an invalid value message that comes from the validation of the local date time, of the locale. And now let's leave this in. The other thing that we should consider is the past. So we create a local date time, and we are saying that the date must be in the past. Of course, every time we run this code and we create the local date time and the getter returns the local date time, the local date time is a bit in the past, a microsecond, a nanosecond in the past. But what we can do is put it in the future. And so if we go over here to local date time and we say local date time now plus 1 day, if we run this, let's run now this specific test, we probably are expecting one single validation. But the problem with that is that the delegate validation happens, it will validate against the delegate, but it will not stop it from returning the value. And so we are expecting two different validations. Let's have a look at the logs and try to understand what happened. Try to make sense of what happens. We see here that there is a default message that must be a past, where it is that let us know that we need a past date. So the date that we've set up in our delegate to be now and a day will never work here. And also we see that we see somewhere that there are two errors reported, and the field error in the delegate rejected value codes constraint. I'm trying to find the locale. Please bear with me. Validation failed for argument 1. Carpar structures because late time validation. Default message. See? So there's default message here. That's the one we already know that it's about our locale validation. And at the end, there's the validation for must be a past date. Now, this is an interesting functionality. I'm not sure how many of you use this in production. I would dare to say none of you, or maybe you are used to using this, and if you are, please don't forget to leave a comment. I really want to know if you have found a production example where to use this delegate use site target. For now, let me just fix this back. So let me put this back to only now, and also fix the local date time validator constraint to accept other countries as, or most countries as in this case. I will now just personally add Portugal because that's where I come from. I will add Spain because I live there also, and I'll add the UK because I also used to live there. And you know what? I'm going to add the US because I've been there. And I'm going to add France because I've been there. Oh, the US is already there. I'm sorry. Anyways, so this tells us that the delegation can work in different ways for us, and one way is using these annotations that can provide us some extra information that we may want to use in our projects. This specific case didn't exactly generate a problem at work because we never actually came across a case that we would be using this, but it did spark the curiosity on where would this be useful in a production case. So we've reached the end of this presentation. And the idea with this presentation is to bring out a lot of important topics to people that are using Kotlin, maybe long-time users of Kotlin, or maybe just new users of Kotlin. And the whole point is to understand that Kotlin, although it provides a lot and it is a huge improvement to other, and it is hugely different to other language and can be seen as an improvement, although that assessment is not very correct in my view. We also need to expect the unexpected in Kotlin as well, just as in any other language. The idea with this presentation is to provide a better understanding of the Kotlin language. Another thing that I want to send out is the message that we shouldn't fight the Spring framework or anything else, like Quarkus, for example. They are not evil and they are not magic. So things that don't work with these frameworks, there's always a reason to it. So the idea is that we can search, we can make better searches to find out what's going on with them. It's also important to read the Kotlin documentation and only use Google or Stack Overflow, for example, as a last resort. The reason for this is that usually the information we need is very much available in the documentation of programming languages, and Kotlin is not an exception. All of this information is on their website. We don't need to look any further than the Spring Framework API or the Kotlin Lang API. Finally, nothing is perfect, and Kotlin also falls into that category, and recognizing that allows us to be better. A bit of a philosophical approach here, but this is really the general idea that I also want to send. If I didn't look at Kotlin with a critical eye, I wouldn't have reached the conclusions that I set out here in this presentation. Finally, what I want to say is send out a big thank you to Sabia and to the Kotlin user group and to JetBrains to making this presentation possible and to allowing me to have the honor of going into the headquarters of JetBrains in Amsterdam to give out this presentation. Again, an amazing time. I really met lots of interesting people over there. I had a very nice social contact with everyone. It was great to know everybody. It was great to have these discussions after my talk. There was a small debate about tailrack and was it useful at all. Someone came up with different questions about tailrack and different ideas, and the discussion was centered around is it better to have an out-of-memory exception, or is it better to have a Stack Overflow exception? Those discussions came along. There was also another question someone asked me about if the compiler is aware of tail recursive functions while not using tailrack as a modifier to these functions. I remember I didn't expect that question, and the best answer I could come up with is that no. But there's a nuance to that question, and that is that the compiler does know that the functions are tail recursive. That's what we see in the logs, in the compile logs. I might make a video about that later on, and this is something that we have seen also in other languages. They do recognize that the function is tail recursive, but it needs to be eligible for recursivity. One of them for recursivity, for tail call optimization, in order for tailrack to work. One of those things is that the function needs to be tail recursive, and the other thing that we need is to apply this modifier to the function. Otherwise, the compiler will say, hey, I know that this is a tail recursive function, but for whatever reason, you didn't let me know that I want to make to apply a transformation to it, and therefore I won't do it, but I will let you know in the logs that this is a tail recursive function, that where tail call optimization may occur. It was a great time, a great evening at the JetBrains headquarters. So again, thank you. And of course, at the end of this video, I always pose this question: are there any questions, and can I help with your questions that you may have about this presentation? Of course, this isn't live, this is just a video, so the best options that you have is just to leave a comment in the comment section of this video. I will gladly help. And if you have more questions and have more generic questions about something else, you can also use the community tab of this channel. Make sure to use it. I will always answer any questions you may have. I have had bizarre questions being asked in this channel and also on my plants channel. People ask all kinds of questions, and I try my best to give a polite and educated answer to any single question you may have. Just don't push it. And finally, these are some of the resources that I've used to make this presentation. Make sure to check the GitHub repository. for this. As I mentioned you before, it's at github.com/myhandler j_Kotlin mysteries. It's very easy to find if you go to my user main page and just simply look for Kotlin mysteries. The source code and the slides are available right now on Scribe and SlideShare. I will post some updates to these slides. There are some things that I had to fix, but most notably, I made a switch in the horn examples. I switched car horned by wagon horn, and that in the code was a bit confusing to see. So I made that clear and better. I've also made some updates to the code in the meantime. If you compare what the code was when I gave the presentation by JetBrains and the code that I now have, one big difference that you may see is that I'm using now TOML for the dependency management, and that is a weight off my shoulders to make updates, and because this is a multi-module project, and if you don't know better, it can be very difficult to generate multi-modules in a Gradle structured project. And these are the links about me. I have a homepage where you can keep up to date with things I do. I namely write articles for Medium. I also write articles for other publishers like HackerNoon, DevTO, and other different ones, but these are the most important ones. For Medium, the articles are a bit more elaborate, and for HackerNoon and the other publishers, I publish everything for free, and you get the benefit that they are purely technical and very much in detail also as well. You can find me on X and you can find me on LinkedIn. These are all the links, and I'll see you next time. So, to wrap up this video, let me just say that if you enjoyed this video, please do all of that good stuff for YouTube to also help support this channel and allow this channel to grow further and reach higher levels. Don't forget to subscribe, leave a like to this video. Again, leave a comment in the comment section. Keep up to date with the community tab. Make sure to participate in discussions that I try to start in there. I have quizzes there every now and then, and make sure to give your answers, and I look forward to reading them. And for the rest, until the next video, have a good one. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video. One more thing I'd like to add is a big special thank you to NL Cook for giving me this book at the end of my presentation. I really appreciate that. Thank you.